In this video, we're going to go use the limit definition of derivative to find the slope of a tangent line to this curve at a specific x value. So we're going to go through step by step, calculate the derivative using the limit definition, and we're going to use this very specific x equals 2 as we go through it as well. So the first thing I'm going to do is use our limit definition there, and I'm going to go ahead and fill in first with x's. So limit as h approaches 0. I'm going to go f of x plus h, the first component in the numerator, is where we replace x with x plus h. So it's going to be 5, instead of x being squared, it's going to be x plus h squared, minus f of x can be replaced with the right-hand side, 5x squared. This is all still over h at this point. The next thing I'm going to go ahead and do is we're using this very specific x equals 2, so I'm going to replace each of the x's with 2's. So we're looking at the limit as h approaches 0, and that's going to get carried along step by step until we're allowed to replace h in the denominator with 0. Right? We can't fill in 0 for h at this point because that would be dividing by 0. That's a problem. Next, I'm going to think that's 5 times, instead of x plus h, it's going to be 2 plus h. On the inside here, we've replaced the x with a 2, minus 5 times, instead of x being squared, it's going to be 2 being squared. Again, replace the x with a 2. From here, it's a lot of algebra. We filled in, that's the difficult calculus step there. Now, most of the rest of this is just being very careful and working some algebra. So the first thing I'm going to do is say that's 5 times 2 copies of 2 plus h. That's what our exponent means, is 2 copies of the same thing multiplied together, minus 5 times 2 squared is going to be a 4, all over h. Again, bringing along the limit as h approaches 0, step by step by step. My next step is I'm going to go ahead and think first, outer, inner, last, and multiply 2 plus h times 2 plus h together. So first, outer, inner, last. Distributive property, just taking our time multiplying those together. And this will be minus 20, 5 times 4 for 20 up in the numerator. My next step I'm going to do, we could either go ahead and combine like terms in our numerator inside that set of parentheses, or distribute. I'm going to choose to distribute the 5 from the outside and bring this to each of these terms on the inside. All right, so it's going to be 5 times 4 makes 20. 5 times 2h makes 10h. 5 times 2h makes another 10h. And 5 times h squared makes 5h squared. We still need to bring along that minus 20 that was at the end and the h from the denominator. At this point, we can go ahead and start combining like terms. We can't plug in 0 for h yet, but we have positive 20 and minus 20. Those will combine together and make 0. Other things that we can combine together in that numerator include the 10h plus 10h makes 20h's. We'll bring along the 5h squared and the h in the denominator. We are almost to the point that we are allowed to plug in 0 for h, but because we still have an h in the denominator, we're running into this problem where we can't put a 0 in our denominator. So to account for that, what we can do is we can remove an h from each of the terms in the numerator, factoring out a common factor, so h comes out. And I do realize there's both a 5 and an h in common, but let's just worry about the h. So it's going to come out, be a common factor. We'll still have 20 plus 5h left in our numerator. Okay, at this point, because we have an h as a factor in the numerator and an h as a factor in the denominator, those will get to cancel out as we simplify down. So we're still looking at the limit as h approaches 0, but in our simplified form, we have 20 plus 5h still left here. We don't have an h in the denominator any longer. So to finish this problem up, what we'll do is we'll replace h with 0. We'll have 20 plus 5 times 0, or 20, is going to be the slope of our tangent line for this function at x equals 2. Because remember, The derivative means the slope of the tangent line from the beginning. So our final answer on this one works out to be the slope of the tangent line will be 20. Now the work would be very, very, very similar if we'd left x involved instead of replacing it with 2 towards the very beginning of this problem. The algebra would work very similarly. You would just have a general form for the slope of the tangent line. You'd know the derivative in terms of x at the end, and we could do it that way if we were replacing with multiple different values of x. It would probably be a better idea to leave it in terms of x until we got to the very end, and then just replace our x's with 2 or whatever other values for x we had at that point. So I hope this helps out. Take your time, work your algebra, and be careful step by step. It's really not that bad of a problem, but it requires a lot of algebra to do well. Good luck.